Hi, we're Team Alpha and this is our Schlieren video presentation. Today we're going to be explaining the physics behind and the processes of Schlieren imaging.
Schlieren works on the basis of temperature and pressure changes within a fluid. The imaging technique works because these variables change, causing the refractive index of the fluid in question to also change.
This means when you shine a coherent light source through the subject area, the light will change direction and velocity in proportion to the changes in initial variables. When the light is projected onto a surface, the refractive index of the fluid changes, showing us lighter and darker areas.
We can see the effects of Schlieren in everyday life. Have you ever witnessed a mirage on the road on a hot summer's day? These swirling patterns are the result of the hot road causing the light above to refract at different angles and appear distorted.
This is our Schlieren setup. It's made up of a piece of A4 paper with inkjet printed lines at a fixed distance of 80 cm from the DSLR camera, on top of a makeshift stand to keep it stable. This was all within a low-lit room so that there isn't any excess light interacting with the system.
With our apparatus in place, we closed the curtains and we were ready to film some Schlieren imaging effects. Here you can see the technique in action. Notice how the projection on the wall behind has dark and light spots, in conjunction with the flame we produced. It's almost as if the flame has a ghost. These swirling patterns are due to the temperature and therefore the pressure changes in the air.
The ideal gas law states that, for this system, pressure is proportional to temperature. The temperature changes, therefore the pressure changes, which in turn changes the direction and speed of the light.
Schlieren imaging has many applications. It is used by aerospace engineers, as the imaging can be used to see the effects of the airflow around an aircraft. This can be used to determine how aerodynamic an aircraft is, by imaging how the air moves around the aircraft. This enables manufacturers to make modifications to their designs for a more efficient design.
This image depicts the aircraft analysis mentioned before, showing the characteristic Schlieren lines around the plane. The darker areas represent the lower density changes in the fluid, whereas the lighter areas depict the higher density areas.
Schlieren optics can also be used as a quality control measure. Glass is extremely hard to manipulate into a perfect shape and is therefore susceptible to defects, so Schlieren imaging is used to check whether a glass pane is free from defects and other issues that could affect its performance, such as varying length or thickness or ripples, stresses and strains, and bubbles.
In industry, Schlieren imaging is done with better tools and much higher precision to extract as much information out of the system as possible. The use of a point source of light, a large parabolic mirror, which is a curved mirror, to reflect light into a focal point are combined to produce a much clearer and more sensitive version of this technique.
The light source is offset horizontally from the focal point of the curved mirror. This then reflects the light to the focal point where a very thin piece of metal, a razor blade for example, is used to block half of the reflected light. A camera placed behind the blade will pick up the light that makes it past the razor blade. The razor blade is very important as it stops the light that has been refracted below a certain angle from entering the camera sensor.
This is represented by the darker areas on the image. This is one of the more basic ways of producing Schlieren images and can be extended to a much more complicated set of different mirrors that accentuate the effect much more.
Schlieren imaging can also be used to measure various aspects and processes within a combustion engine. It is used to capture the spray evaporation and spray interference from fuel injectors, as well as the resulting effects when fuel and air mix within the engine and the implications that this has on the ignition of the engine.
Thanks for watching guys, hope you enjoyed the video. Schlieren you later!